The natural exponent function. A number that appears in formulas when the exponential growth or decay is happening continuously or nonstop is the number e. This value, much like pi, is a never-ending decimal or an irrational number. One of the many ways it can be approximated is with the formula 1 plus 1 over x all to the power of x as x gets larger and larger and larger. So the larger x becomes, the more accurate an approximation of e becomes. To 12 decimal places, here is a representation of e to 12 decimal places, but of course it keeps going on forever. It never repeats or makes any kind of a pattern. To access it on your calculator, almost without exception, when you're dealing with the number e, it has an exponent with it. So if you'll push second and then the button that says ln, you can see the little e to the x right above it. That's how you'll access e, and then it'll be waiting for you to put the exponent with it. So let's work some problems that have e in the formula. This is a exponential decay problem. A substance decays in such a way that the amount of mass in kilograms remaining after t days is m of t equals 5 e to the power of negative 0.07 t. Part A, find the mass at time 0. So the mass when time is 0 would be 5 e to the negative 0.07 times 0, which is 5 times e to the 0, and hopefully you remember that anything to the 0 power equals 1. 5 times 1 then is just 5 kilograms. Anytime a problem asks for an initial value, it's asking for the value at the start of the time period, so when t equals 0. So what we just found was an initial value. Then it says how much mass remains after 100 days, same kind of process. The mass after 100 days is 5 times e to the power of negative 0.07 times 100. And then you would put that in your calculator all at once, and it comes out to be 0.005 kilograms. So it's decaying at a specific rate, which involves the number e, and you can plug in the number of days and see how much of the substance is left after that many days. This is a logistic growth model, and the description says animal populations are not capable of unrestricted growth because of limited habitat and food supplies. Also, predators would have an effect on this. So under such conditions, the population follows a logistic growth model. So this formula takes into account the fact that you could not have unrestricted growth. An animal population is not just going to grow and grow and grow without stopping. So in this formula, it's a little bit hard to read. This part right here is negative c times t. And those are all constants that would be specific to the situation. And this problem says, for a certain fish population in a small pond, D equals 1200, K equals 11, C equals 0.2, and T is measured in years. The fish were introduced into the pond at time T equals 0. That's the initial value. That's the initial number of fish. And so part A says how many fish were originally put into the pond. So we need to find the population at time 0 and just fill in the numbers that you were given for those constants. D is 1200 over 1 plus K is 11, e to the power of negative 0.2 times 0 for time. So the e, this is going to be e to the 0 again, which is just 1. So on the bottom we've got 1 plus 11, which is 12. And hopefully you can get that 12 into 1200 would be 100. So there would be 100 fish in the pond. Now if you did put all that in your calculator at once, you would want to make sure you put all of the bottom, all the denominator in its own parentheses so that the calculator knows what's on top and what's on bottom of the fraction. Part B, draw a graph of the function p of t. So you would have into your y equals in the calculator, you would have 1200 divided by parentheses 1 plus 11 e to the negative 0.2, and then you'd have to use an x where they have a t because your calculator doesn't have the t. You would just use the x. And be careful about all your parentheses. So that's what you would put into the y equals of your graphing calculator, and you would use this window I've given you. And in your notes are the windows for your homework, so make sure you look at your notes for that. And so you can see the fish population growing, 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 but then the growth starts slowing down and then it levels off as the pond is sustaining the maximum number of fish that it can handle. So there's the graph. And then it says, what size does the population approach as time goes on? In other words, as it levels off, what is that population? The y-axis is the number of fish, and the x-axis is the time. So you can see that it levels off, and to find that value, you're going to push the trace button. Now, a lot of times we push second trace to get to a menu we use for graphs. But you'll just simply push trace and push the right arrow and follow the graph along until after a while the y stays at 1200. So you can see it's a lot of years until that happens, 120 years, and then there are 1200 fish is the most, well actually it would hit 1200 back here. I just scooted the cursor over to 120 years. But 1,200 fish is the maximum number of fish that pond can hold, that the pond can sustain. Another common use for the number E is in continuously compounded interest. The formula is pretty simple. A of t, which is the amount of money you have after a certain number of years, is equal to P, which is the principal, the amount invested, times e to the power of R, which is the interest rate. Remember how you have to convert percents to decimals by moving the decimal point 2 places to the left, and then t is the time in years. So these are just simple fill in the formula problems. It says if you invest $7,500 in an account paying 5.35% interest, compounded continuously, that's how you know to use this formula, is the word continuously. How much will you have after 5.5 years and after 12 years? So remember the interest rate, move the decimal 2 places to the left, 0.0535. Now we just fill in the formula. The amount after 5.5 years is 7,500 times e to the power of 0.0535 times 5.5. And you just put all that in your calculator at once, and it comes out to be 10,065.95. And then when you have to do it again, to do the 12 years, if you just push second enter on your calculator, it'll call this entry back up, and you can just change your 5.5 to a 12 and not have to retype all that, unless you just want to. And it should come out to be $14,252.08.